Shape is the dimension that falls under the measurement strand of the mathematics domain. Geometry is a branch of mathematics concerned with the properties and relations of points, lines, surfaces, solids, and higher dimensional analogues. Shape is a component of this that relates to the understanding of attributes of objects and the relationship between them.
So why? Why is this topic important in early mathematical teaching? Children's earliest explorations of the world are pre-linguistic, pre-number, and mostly spatial. Thus, children come to school with the ability to interact with shape, which is not common in other mathematical dimensions. Highlighting and linking to this prior knowledge will help consolidate their mathematical foundation and provide an opportunity for students to discuss their personal insights. Shape is a unique topic, as it can be used to facilitate learning in mathematical concepts, such as models for fractions, area models for multiplication, and patterns that can then lead to algebraic expressions. Furthermore, such familiarity with shape enables students to develop their communication skills, associated language, and confidence in ability.
Oh, hello there. According to Oswells, at the foundational level, students need to be able to sort, describe, and name two-dimensional shapes and three-dimensional objects in the environment. This is a square, and these are all squares, even though they're different sizes. According to Oswells, at level 1, students should be able to recognize and classify familiar 2D shapes and 3D objects using obvious features.
Hey Em, can you find me a triangle?
This is a triangle because it has 3 sides.
Okay, according to Oswells, at level 2, students should be able to describe and draw 2D shapes with and without digital technology, and also describe the features of 3D objects.
So I drew a square. I know that this is a square because it's got 4 points, 4 edges, and they're all the same length.
One of the trickier 3D shapes that we've been learning about is a square-based pyramid. I know that it's square-based because it has a square underneath. It has 5 faces. One of them is a square and 4 of them are triangles. It also has 5 vertices, which is a fancy way to say points.
Big ideas that underpin our topic of shape start with describing and sorting. So starting the topic with these ideas in mind will help teachers establish what prior knowledge students have. It will also help in understanding what their representations of shape are. Furthermore, sorting will help correct any misinterpretations prior to exploring and building foundations of shape. Exploring and discovering. Moving through this stage, students will have the opportunity to engage with 2-dimensional and 3-dimensional objects with a hands-on approach. It will foster the development of appropriate language and also center the child in their learning. Representing and constructing. Allowing students to build and find their own shapes will demonstrate their level of understanding. This process will help students to gain confidence in interacting with both formal and informal objects. In addition, they would be able to highlight differences and similarities.
In our Week 4 lecture, Jill discusses the issue of children forming prototypical views of shapes and how this can lead to misconception. She explains that children begin forming concepts of shapes long before they enter school. Their first interaction with shapes are generally from play-based activities like these. Hence, they may first recognise shapes by their overall appearance alone. For example, they could say a rectangle is a rectangle because it looks like a door. Or they might focus on one aspect of a shape, calling a triangle because it's sharp. And sometimes children can perform well using such thinking. They can accurately identify circles and squares despite tricky distractors. They do not, however, perform as well identifying rectangles or triangles. Children might be able to identify this as a triangle. However, they may not be able to identify these as triangles because they don't conform to the image that they have developed in their head. Okay, so what's the solution? There needs to be greater emphasis in classroom programs on identifying shapes according to their properties rather than their appearance, to enable children to develop richer concepts of shapes. Teachers should present plenty of non-examples as well as examples and take care not only to show prototypical shapes.
Furthermore, there has been extensive research into the selection of shape-based resources and materials. Clements and Batista discuss that most of the materials used to introduce shape to children only show the best examples. Stereotypical images reduce students' ability to identify shapes in complex situations as they rely solely on their appearance. In addition, there are even programs that actually go against students' correct perceptions of shape. For example, when a student was using a shape-based program on the computer, it asked her to choose a square fish. She selected a fish that looked like this, and the program announced that she was wrong, as it said it was a diamond fish. She argued that this was in fact a square as it has 4 equal sides. It was just turned on an angle. So what's the solution? To help children break free of these limitations, teachers need to vary the size, material, colour, orientation, and dimension of the shape. Mathematical understanding is enhanced when a child observes and explores an object, thinks about and tests an idea, and communicates findings as well as asking questions. We feel that these activities of behind the wall, the feely bag, and making an ice cream cone connect and correlate well with our big ideas and the research that we previously discussed.
Okay guys, so I've got some shapes behind this wall. I wonder if you can guess what shape is popping up behind the wall. Alright, first shape.
The triangle!
Why is it a triangle, Lucy?
Because it's got a point.
Yeah, you're right, it's a triangle. Okay guys, today I've brought my little feely bag into class. Now, in this bag, I have some special 3-dimensional shapes. Now, does anyone think they can come up and pick a shape and describe the shape?
I
in
do.
class? Come on, Lucy. Alright, now don't look. Now put your hand in and feel around for a shape.
It's got some points on
Okay.
it, some vertices.
Yes.
And from what I can feel, it's got 1, 2, 3. It's got 4 faces.
Okay.
And they all feel like they're the same shape. So I think I've got a triangular pyramid.
Okay, let's pull out the shape and see if you're on. Oh.
Ta-da!
Okay guys, today I'm going to set you the challenge of constructing your own 3-dimensional shape. Now don't tell me what the shape is now. Once you've cut it out and stuck it together, then you can come and tell me what this shape is.
There you go guys, a video on how to teach shape.
We hope you found it insightful and helpful.
Peace out.